Hello student, good morning. I am Dr. Ajay Kumar Sinha, Professor of Chemistry. Today I am going to start new chapter, States of Matter, means a gaseous state of matter. First I will review fundamentals of this chapter. After that I will discuss important multiple choice questions. Now I am going to review of fundamentals of a state of matters, means gaseous state of matter. Actually it is in two parts, part 1 and part 2. States of matter part 1, states of matter part 2. Then now I will discuss gaseous state of matter part 1. Okay, I will review it and then I will discuss multiple choice of questions. What is a state of matters? What is the states of matter? Then now I am telling you. Matter exists in three states. First, solid, second, liquid, and third, gas. All the three phases can exist together at a particular temperature and pressure. Means ice can convert to water, water can convert to water vapor. Okay. Then these ice, water and vapor can exist together at the fixed temperature and pressure. What is that fixed temperature and pressure? Then temperature is 0 degrees centigrade and pressure is 4.7 mm pressure. Remember, question is asked. Ice, water and water vapor can coexist at a fixed temperature and pressure. Temperature is 0 degrees centigrade and pressure is 4.7 mm. Okay. Now I will discuss what is the characteristics of a solid, liquid and a gas. These are very fundamentals because you will answer many questions you can answer on the basis of these concepts, these characteristics of solid, liquid and gases. Now I am telling you, I will compare all three point by point. First, solid you consider. In solid, molecules are closely packed, and in liquids, molecules are less closely packed, and in gases, molecules are sufficiently apart from one another, means they will make distance. In gases, molecules are sufficiently apart from one another. Now second point, mutual forces of attraction are the strongest in solids. In solid, mutual forces of attraction are the strongest, and in liquid, mutual forces of attractions are weaker than those in solid. Mutual forces of attractions are weaker than those in solids, and in gases, mutual forces of attraction are almost negligible. Now third point, the density of solid is high, but in liquid, the density of liquid is lower than that of solid, but is much lighter, much higher than that of gases. Again I am telling you, the density of liquid is lower than that of solids, but is much higher than that of gases. Now come to the gases. Gases generally have low densities, correct? Means in solid, density of solid is high. In liquids, the density of liquid is lower than that of solids, but is much higher than that of gases. And gases generally have low densities. Now, next point I am telling you, that is the fourth point. The positions of molecules in the crystal lattice are fixed, and hence exits solids do not have translatory or rotatory motion, but only possesses vibratory motion. Question is asked. Here you should remember the position of molecules in the crystal lattice are fixed, and hence solids do not have translatory or rotatory motion, but only possesses vibratory motion. Means vibration will be there. Correct? They don't have translatory or rotatory motion, but have vibratory motion. Now liquids. Molecules of liquids have greater freedom of movement. They have some translatory and rotatory motion in addition to vibratory motion. Means both type of motions are present. Translatory and rotatory motion in addition to vibratory. Means translatory, rotatory and vibratory motion, all three are present, but translatory motion are less, some only. And in gases, molecules of gas have large rotatory, vibratory and translatory. All three motions are large, but in liquid, translatory motions are there, but very less. Okay. But in gases, all three are more. Now next point I am discussing. Molecules of solid possesses least energy. Molecules of solid possesses least energy. But in gases, molecules of a liquid have higher energy than that of solids. And gas molecules are most energetic. In all three you can see, in solid, because molecules are not moving, they are almost fixed. That's why they have least energy, but liquid molecules are moving. That's why they have more energy than solid. Molecules of a liquid have higher energy than that of solid, because here in liquid molecules are moving, and in gas molecules are most energetic, because they move fast. Now next point, solid have both a definite shape and a certain volume. Any solid you can see, its shape will be fixed and volume will be also fixed. Solids have both definite shape and definite volume, but liquid do not have these things, shapes, fixed shapes, definite shape. Liquids do not have definite shapes but have definite volume. Suppose 500 ml water is there, then volume will be 500 ml, but you can keep in different you can say utensils of different shape. Total volume should be 500, but shape may be different. Correct? Utensil shape may be different, but total volume will be 500 ml only. That's why liquids do not have definite shapes but have definite volume. Gases neither have definite shapes nor definite volumes. Correct? Both are not fixed. Gases neither have definite shapes nor definite volumes. Now next point I am discussing, solids possesses least compressibility and thermal expansion. Means you can't compress further. Very least compressibility. You can't compress too much. And if you will heat, expansion will be very less. Thermal expansion will be less. That's why solid possesses a least compressibility. You can compress very very little you can compress. There will be very little change if you will pressurize it. Okay, that is called compressibility. Solids possesses least compressibility and thermal expansion, means it will not expand too much, very little expansion. And if you will compress it, if you will press it, then again you can't make so much change. Now liquid have slightly higher compressibility and thermal expansion than those of solids, because it will expand more. You have seen milk, if you are heating, then suppose if you are heating and milk is 500 ml, then if you heat, then expansion will be more. It will come out from the utensil. It will look like 1 liter on heating. Correct? Then this actually expansion telling about the compressibility. Then liquids can be compressed. Okay, liquids can be compressed more than solid, and expansion is also more than solid. And liquids have slightly higher compressibility and thermal expansion than those of solids. And gases possesses high compressibility and thermal expansion, means gas can expand very fast. Correct? It will expand more, means compressibility is also more in comparison to both solid and liquid. Gases possesses high compressibility and thermal expansion. This I have comparatively I discussed about general characteristics of solid, liquid and gases. Many question you can answer on the basis of characteristics of solid, liquid and gases. One more things I want to discuss it, that is the expressing mass, volume, pressure and temperature of gas. Expressing, how will you express mass, how will you express volume, how will you express pressure and how will you express temperature of a gas. Okay, then here we know that number of moles is equal to what? Number of moles is equal to, already many times I discussed, mass in grams divided by molar mass. And mass of gas is determined by weighing the container containing the gas, then evacuating it and weighing the empty container again. That you know. How will you mass, how will you know? Then total mass minus empty. Correct? Mass of a gas, how will you measure? Then total mass of the container in which gas is there. And after that, without gas, what is the mass of the container? Then difference is mass of gas. Mass of gas is determined by weighing the container containing the gas. And after that, then evacuating it and weighing the empty container again. And volume, how will you measure? Then already I discussed 1 liter is equal to 10 to the power minus 3 centimeter cube, means cc. 1 liter is equal to 1000 cc. Also you can tell 1 liter is equal to 1 decimeter cube. Many other things are there. I will discuss in the next class. That is related to mass, volume, pressure and temperature. Many formulas are there that I will discuss because I am reviewing the entire chapter. Means a state of matter, gaseous state of matter I am reviewing. Then slowly and slowly I will review all this chapter, gaseous state chapter first part. I will just review it. Okay, after reviewing, then I will come to the multiple choice of question. Now, today I am stopping all here. Thank you.